Next, for our third finalist, we have Adi Goldman, co-founder and CEO of Biotic. Welcome him to the stage. Stand right there.
Hi, thank you for having me while waiting for the presentation to come up. Did you know that only 9% of global plastic consumption is being recycled? The rest ends up in landfill, finds its way to our natural resources, and we end up consuming a spoonful of microplastic on a weekly basis. I'm Adi Goldman. I'm the CEO and co-founder of Biotic, and my family has been traveling, hiking, and camping since forever. In the last decade, it was very hard not to witness the amount of trash that is piling up in the sides of the roads, the parking camps, the rivers, and the hiking path. As the kids grew, they also started noticing the harm created to the environment. They become more aware of the situation, started collecting trash along the way, and asking a lot of questions, as kids usually do. In the process of explaining to them the harm caused to the nature, my twins and I realized that the figurines they were playing with are made out of plastics, which made us look around and realize the amount of plastics that we are surrounded with. Their backpacks are made out of plastics, their hairbands, computers, hygiene and medical products, clothing, and basically everything, literally everything they and I come in contact with includes some form of toxic plastics. So after a decade working in the heavy industry, visiting factories across the world, witnessing the pollution emitted to the environment and the damage caused to our natural resources, provided me with motivation as well as established connection to develop and produce a change with a hope of a healthier and better future for our kids. Biotic envision a world where plastic is no longer a concern, in which the consumer, us, purchase the product in the exact same way, and after use, we just toss it to any trash without the need to sort, recycle, or worry. Biotic uses marine biomass and precise fermentation to produce fully biodegradable PHBV polymers. Basically, our polymers can do anything that plastic can, but it's made out of algae. Biotic uses untreated seawater in the process, reducing energy consumption and cost, as well as reducing contamination risks, allow us to work in a non-sterile environment, increasing production capacity drastically. We use no harmful chemicals throughout the process, and we extract valuable byproducts, targeting to have as minimal waste as possible. And closing the circle, our polymers fully biodegrade in any environment back into CO2 and water. Our funding team includes serial entrepreneurs with numerous background companies, and the entire team bring together shared passion for the environment and extensive experience from various fields, including metabolic engineering, precise fermentation, marine biotechnology, regulation, business, and scaling up. Until today, most of the bioplastic ecosystem uses terrestrial resources and fresh or treated water in their processes, which usually leads to very high cost and tend to provide a niche solution. Biotic uses marine biomass, which is already naturally grown all over the world, in every ocean, all year long, has positive environmental effect, does not compete with arable land, and our products, our polymers, fit existing production line and industrial needs to allow seamless transition. And all of this with a simple goal of having that also in the same price as fossil-based plastics to allow an even simplest transition. As a commodity manufacturer producing bioplastic flakes or pellets, our customer range across all industries. Our polymer can serve anything from very flexible to very ruggedized products and anything that's in between. And we are currently working on product optimization and while conducting pilot project with Fortune 500 companies and global corporates. We have achieved a lab-scale proof of concept and a bioreactor process scaling up by 100. We have established a semi-continuous process and are working on additional process optimization to increase capacities, efficiencies, and reduce costs. The Aviram Award Tech for Humanity will assist us tremendously in expediting Biotic's vision and achieving market penetration. And winning the award will allow us to expedite our in-house production capabilities to hundreds of kilograms of polymers per month, increase the numbers of polymers that we can produce, and achieve market validation by industry leaders. Together, we can achieve Biotic's vision and transition the planet from fossil toxic plastics for a future of a better world and for the future of humanity. So, thank you very much for having me today.
Thank you. You were perfectly on 5 minutes, I saw on the counter. That was very impressive.
Practice makes perfection.
Yes. Let's turn over to our judges and let's get some questions. Who would like to go first? Fatima.
Yeah, I'll do. How can you convince the manufacturers to buy your product rather than the normal one?
There are steps to do. I think the first one is to show them that it can work through their existing production lines. So this is the next step that we are going to do. We already have a list of companies that are looking to see that. And second is that we can reduce the price to match the price of fossil-based plastics. I think these are the biggest two tackles or challenges that the industry has today. And by showing that, I think the sky's the limit because everybody wants to replace the plastics with biodegradable alternatives.
So how different is your price point currently, and where will it be with the investment?
In general, I would say that polymers that are existing in the market since early 70s today are 4-5 times the price of fossil-based plastics and north of that. If we scale up today the process that we have, we can reach the same price point, which is already very good. We target to be at the first tier, so 12 months from now, at about 2 times the price of fossil-based plastics. And at the end of 2 years development, we target to be at the same price of fossil-based plastics. We already did a lot of decrease in pricing, moving to a non-sterile environment, continuous operation, and using seawater reduced the overall cost of the process drastically compared to available alternatives.
I have 2 quick questions. So you mentioned that you're going to be using seawater. So when these products degrade, will that add salt to the overall landscape, which could be harmful to vegetation?
The other way around, actually. One of our targets is to collaborate with desalination plants. Usually today, desalination plants, the salts that they take out, they push back to the water. We can take the salts into our processes. The polymer that comes out is salt-free, so there is no salt, and the water goes back into the production.
So this is biodegradable plastic that you plan to use for all sorts of use cases, including things like, I'm assuming, shampoo bottles. So how do you determine how much time it's going to degrade and prevent it from degrading before the consumer is ready for it to do so?
So there are many aspects to answer this question, but I think that there's 2 steps. One, we can control the few of the characteristics of the polymer, so to suit it to longer time period or shorter time period, that's one. Secondly, it depends on the size of the plastics. So a straw is very thin, so it might take shorter time to degrade. In any way, it will not biodegrade in your glass. It takes, in an ocean environment, which is very active, it takes somewhere between a month to 2 months, so already a good thing. As we will grow, we will also add additives which are fully biological. Some of them we can take out of the algae itself as a byproduct and stitch it together so that we have a better working plastics, for example, in terms of detergents, which have very active material inside. You want it to hold for 7 years or 10 years. So yeah, we have this in our vision to address this as well, and there are solutions that we have in mind.
Yeah, real quick, there are multi-million-dollar companies that make this sort of thing already. Like, how are you going to compete, and how is your polymer different than places that are already fully actively running and building these things?
So as I mentioned during my pitch, most of these companies are using terrestrial resources. The ones that you probably have in your mind are using terrestrial resources. This is very limited. If you think of replacing 400 million tons of plastic, $600 billion market, we cannot do it with agriculture products or waste. We need alternatives. So that's one thing. The other thing is that they usually focus on one polymer that suits one product or a group of products. For example, a box. We are coming from another direction. We want to be a commodity manufacturer which has a line of product that can fit anything from very ruggedized to very flexible, and anything that's in between, including clothing and wearables, and at the same price of fossil-based plastics. Those companies are the multi-million dollar companies are necessary for the environment as well, but we need something else to support growing to 400 million tons.
Right, I want to say such a huge thank you for you two
Thank you
being
very
so
much.
patient with the technology. Thank you.
Thank you.